Hello and welcome to Manage and Configure Repositories. I'm Andrew Conniff, a Microsoft Technical Trainer specializing in data and AI. And today we are going to explore this important topic. So let's dive right in. Managing repositories is about organizing our code in a way that promotes collaboration and security. Repositories act as a central hub for our source code, so enabling teams to work together efficiently is important. By configuring repositories properly, we ensure that branching strategies, permissions, and policies all align with our development workflow. Git repositories work by distributing the codebase to developers, and this provides many advantages. However, some disadvantages do exist as well. Typically, the disadvantages are that the clone instance is too large. Reasons for that could be that the repository has very long history or contains very large files. So for repositories with a very long history, we can clone at a shallow depth. What that means is we don't need to see the full history. So we only go as deep as we need to perform the work that we need to perform. For repositories where we have too many large files, we can work with repositories that have large file support, or LFS. Of course, the files we typically see in SharePoint, like PowerPoint presentations and Word documents, should not be kept in a Git repository. And this is because those file types change versions based on the host computer. And even if the file is untouched, we're checking in a new version of the file each time, and that's going to bloat our repository. Scalar is a .NET Core application and Git extension designed to optimize performance when working with very large repositories. Scalar caches metadata and uses background maintenance to accelerate Git commands, making operations like cloning, fetching, and logging much faster. Key features include partial clone, which reduces the initial download size, background prefetch, sparse checkout, file system monitoring, commit graph acceleration, multi-pack index, and incremental repack. Scalar has cross-repository sharing, which allows code and resources to be reused across multiple Git repositories. And to optimize repository structure, it's recommended to break down larger repositories into smaller modular ones and then use Git submodules or sub-repositories. When organizing our code base, you're often going to hear about two major philosophies. One is the monorepo approach, and the other is the multiple repos approach. A monorepo is having all of your source code stored in one big repository. This makes it incredibly simple for teams. Everyone gets access to everything with a single clone, which can be a huge time saver for onboarding and collaboration. Monorepos are especially handy when you want to keep things unified and make it easy to share the code across different projects or teams. On the other hand, multiple repos, or that strategy, means each project potentially lives in its own separate repository. This setup allows subteams to work independently, focusing on their specific area without worrying about changes in unrelated projects. The core difference between these two philosophies comes down to what helps your teams move the fastest. Monorepos offer simplicity and broad access, while multiple repos provide autonomy and flexibility. Choosing the right approach depends on your organization's size, workflow, and how closely your teams need to collaborate. A changelog is a vital tool in software development that helps teams keep track of every modification made to a project over time. So think of it as a running diary for your code base, where each version gets its own entry, detailing its new features, changes, and anything that's been removed. This record can be created manually by writing out updates as they happen, or automatically using tools to pull information straight from your version control system. The main goal is to provide a clear, organized history that's easy for anyone on the team to review. This makes it much easier and simpler to understand when it's been changed and why. Now, you may also need to clean up your Git repository, whether it's to reduce its size, remove accidentally committed large files, or to rid yourself of sensitive data like passwords. Choosing the right tool is crucial. Historically, many developers use Git filter branch for these tasks, but this tool has a reputation for being slow and prone to subtle errors that can make your repository's history confusing or even corrupted. Because these issues can't easily be fixed, we're now recommending to avoid Git filter branch altogether for history rewriting tasks. Instead, the modern solution is Git filter-repo. It's a versatile and efficient tool designed specifically for rewriting the Git history. So unlike its predecessor, Git filter-repo offers better performance, more capabilities, and a design that scales well for both simple and complex repository cleanups. It's now the recommended tool for safely and effectively purging unwanted data from your repository. When you need to recover lost or specific data in a Git repository, there are several handy commands at your disposal. You can use git log to review commit history, git checkout or git cherry pick to restore commits or files, and git restore for individual files. For more granular recovery, git blame and git show help pinpoint changes line by line. If you've accidentally deleted commits or branches, git reflog or git fsck lost found can help you track and recover them. So remember to back up your repo or use git stash before making major changes, as these tools are powerful but require careful handling to avoid further data loss. Managing releases in GitHub is all about organizing and sharing the progress of your project in a clear, trackable way. In GitHub, releases are based on tags, which act like a snapshot of your repository at a specific point in time. When you're ready to make a new version, whether it's a major update, a bug fix, or a feature release, you create a release tag using the GitHub CLI or the web interface, and this tag captures the exact state of your codebase, making it easy to reference, download, or roll back if needed. The process is straightforward. You use commands like release create tag to generate a release, and you can even add notes and titles to describe what's new in that version. The benefits of using GitHub releases go beyond just version control. Releases help teams communicate changes to stakeholders, distribute new features or fixes efficiently, and maintain a reliable history of the project's evolution. So each release can include downloadable assets, detailed notes, and links to related issues or pull requests, making it central for collaboration and transparency. Documenting your API is essential for helping team members and stakeholders understand how to use and integrate with your software. In Azure DevOps, it's best to use dedicated documentation tools that fit seamlessly into your development workflow. Some popular options are Swagger, which is open API, API Blueprint, or Markdown-based systems like MKDocs or Docusaurus. You can publish this documentation to a central location, such as a website or a wiki within Azure DevOps or an external portal, making it easy for everyone to access the latest information. Adding code annotations and decorators directly into your source code helps API endpoints, and setting up automated process in your Azure DevOps pipelines ensures that the documentation is always up to date whenever the codebase changes. When working with GitHub, you can take advantage of the tools built into the ecosystem to generate and publish API documentation. To share your documentation, use GitHub Pages to host static websites directly from your repository, and set up GitHub Actions to automatically build and deploy updates whenever the documentation or code changes. This approach keeps your API documentation accessible, current, and easy to maintain for your entire team. Automating Git history documentation is all about making your release notes and API documentation effortlessly and reliably. By integrating tools like OpenAPI or other documentation generators into your CI/CD pipeline, you can automatically produce up-to-date API docs every time your code changes. This means that your team and stakeholders always have access to the latest information. It's going to be published in a central location, such as GitHub Pages or Azure DevOps wikis or other document hosting services. You can also use Git commands or specialized tools like Git changelog to generate release notes directly from your Git history. Customizing the format to suit your project's needs is really an easy thing to do. The real benefit of this approach is consistency and efficiency. So instead of manually updating documentation or release notes, which can be time-consuming and error-prone, automation ensures that every change is captured and published without any extra effort. This streamlines collaboration, keeps everyone informed, and reduces the risk of missing important updates. By integrating release notes and documentation into your development pipeline, you create a transparent workflow that supports both rapid development and high-quality communication across your teams. GitHub's permission model is designed to fit a variety of collaboration needs, and it differs depending on the type of account you choose. There are 5 main account types for individuals and organizations, each offering different levels of control and flexibility. For private repositories, you can have only one owner and up to 3 collaborators, with collaborators limited to write access. This setup helps maintain security and clarity over who can make changes. GitHub also includes powerful collaboration features like protected branches and code owners, which ensures that only authorized users can modify critical parts of your code base. For organizations, GitHub takes things further by allowing owners to set the permissions and customize access using built-in or custom roles. This means you can tailor access to different teams, restrict repository actions to specific IP ranges, and take advantage of enterprise-grade authentication for added security. Branch-level permissions and custom roles give you granular control over who can do what, making it easier to manage large teams and complex projects. These features are especially valuable for teams and organizations that need to balance collaboration with robust security and compliance requirements. Assigning tags in a GitHub repository is a straightforward way to organize and mark important points in your project's history, such as releases or significant commits. To tag a specific commit or release, first locate the commit hash or release version in your repository's history. If you're tagging a commit, copy its hash. For release, use the version label like v1.0.0 in your local repository and use the command git tag, which is the tag name and then commit hash. You're going to use that to create the tag and then push it to the GitHub git push or origin tag name. You're going to use that command. Once pushed, you can verify that the tag's creation by checking the release tags page in your GitHub repository. For added control, GitHub allows you to set tag protection rules to prevent contributors from creating or deleting tags. Though as of March 2024, these rules are still in beta and may change. Tagging does still help teams keep track of versions, organize releases, and maintain clear project history. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.